Scientific notation helps to develop an understanding of large and small numbers. It also relates to the laws of indices. For example, scientific notation is a times 10 to the k, where a is a number between 1 and 10, and k is an integer. For example, 3.5 times 10 to the negative 5th and 6 times 10 to the 12th are two examples. These are not examples. 27 times 10 to the 6 is wrong because 27 is not between 1 and 10. Same thing between 0.5 times 10 to the 8th. 0.5 is not between 1 and 10. To write numbers in scientific notation, you're basically moving the decimal place from its point over to create a number between 1 and 10. So for example, in 23,500,000, you need to move your decimal place 2, 3, 4, 5, 6, 7 spots, leaving you 2.35 times 10 to the 7. In 0.000005, you have to move your decimal point all the way over to in front of the 5 so that you get the number 5 between 1 and 10. In this case, that's 1, 2, 3, 4, 5, 6 spaces. So you get 5 times 10 to the negative 6. Negative because it's a small number, positive is a really big number. Okay, large numbers and small numbers. To work in the other direction, you take a number, for example, 6.75 times 10 to the 6th, and you need to move the decimal place over by 6. So you make it 6 over, and you fill in zeros into the empty spots, leaving you 6,750,000. Another example, 7.865 times 10 to the negative 3. Remember, negative means a small number, so I have to move my decimal place back by 3. Again, filling in the empty spaces with zeros, you get 0.007865. How does it work when you're working with the laws of indices and doing multiplication or division? For example, you can take a look at these two examples. When we're multiplying two different numbers with scientific notation, we multiply the numbers, so 3 times 8 giving us 24, and then we add our exponents, right? 10 to the 4th times 10 to the 3rd means adding the exponents. Now, because our 24 is a number not between 1 and 10, we need to move our decimal place over by 1, which is where the 10 to the 1st comes in, so that we have our number between 1 and 10. And then we have 10 to the 7th, that's the 4 plus 3. We then add my 10 to the 1st and my 10 to the 7th, and I wind up with 2.4 times 10 to the 8th. In this second example, you're raising it to the 3rd power, so therefore you have to raise everything inside the parentheses to the 3rd power. So the 5 gets raised to the 3rd power, and the 10 to the negative 4th gets raised to the 3rd power. That gives you 125 times 10 to the negative 12th once you multiply. But again, we have to make a number between 1 and 10, so we move our decimal place by 2, bringing in the 10 to the 2nd. When we put 2 and negative 12 together, we get 10 to the negative 10. Now give these two a try, pause the video, and see if you can get the correct answer. The answers will follow. Now here are your answers. Any questions? Ask them in class tomorrow. Okay, now how does it work with division? Well, it's the same idea as multiplication, except now we're going to divide our two numbers, and we're also going to subtract our exponents, because that's what the law of indices tells us when we divide things. So in this case, we have our 8 divided by 2, and then we have 10 to the 4th minus negative 3. That gives us 4 times 10 to the 7th. Since 4 is a number between 1 and 10, we can stop here. Now in our second example, we have 2 divided by 5, so that's going to give us 0.4. We do minus 3 minus negative 8, giving us positive 5. Now we've got to move our decimal point in the other direction this time, so it becomes 4 times 10 to the negative 1 times 10 to the 5th. We put the negative 1 and 5 together, and we get 4 times 10 to the 4th. Here's a couple for you to try. Give them a shot, and then pause and come back and see the answers in a moment. Now here's your answers. 2 times 10 to the 3rd, and 1 times 10 to the negative 19th. Again, copy these down. Any questions, ask in class tomorrow.